Okay, today we're going to just be discussing velocity time graphs. We've seen something similar to this when we did the position or distance time graphs earlier in this unit. Velocity time graph is a visual representation of acceleration. And remember, acceleration is a change in velocity over time. Sometimes you may have positive acceleration, which means there's an increasing velocity. So positive acceleration indicates increasing velocity. And you'll see that here in the first part of the graph, the first 10 seconds. Okay, so in the first 10 seconds, you see that this object is starting at 0 meters per second. Over that 10 seconds, its acceleration is increasing, which means it's changing over the entire 10 seconds. And then sometimes you have no acceleration or zero. Okay, zero acceleration. And that means their acceleration is remaining constant. All right, that doesn't mean it's not moving. It just means acceleration is remaining the same over the period of time. And then you have negative acceleration, which means you have a decreasing velocity. As with our other graphs, the steeper the line, the greater the change. Okay, so what the heck do I mean by that? This line indicates a certain rate of change over time. If this line were steeper, the velocity would be greater. If it were not as steep, the velocity would be less than what it is now. You'll notice over this 10 seconds, this object is getting faster and faster and faster. Its speed is increasing. And over this 10 seconds, the second 10 seconds, it's remaining constant. And in the last 10 seconds, it's slowing down at an increasing rate. So it's getting slower and slower and slower. All right, so the steeper the slanted line, the greater the change in velocity. Positive acceleration is going to be indicated by a line that's going up over time. Zero acceleration is indicated by a flat line, and negative acceleration is indicated by a line that's coming down over time. There are two scenarios where you're going to have zero acceleration. In this example, you have an object that's moving in a straight line at a constant speed or velocity. All right, because the speed is staying constant, its velocity is not changing. Because it's going in a straight line, its velocity is not changing, so its acceleration is zero. On this side, you have an object that's speeding up. So after 1 second, so what that's basically saying is it's accelerating at an uneven rate. When we did the timelines before, we had all the same rates of acceleration in our examples, right? So this would be like in the first second, it might be accelerating at, let's say, 0.5 meters per second. But in the second second, it's increasing at a rate of 1.0 meters per second. So it's accelerating more quickly. The other scenario where you would have zero acceleration is if the object is not moving. All right, if there's no motion, there's no change in velocity. So another object where you'd have zero acceleration is where there's no motion. Okay? As with the positive acceleration, you have negative acceleration. And if it is a slanted line, that means it is changing over time. So in the first half second, you might decelerate, okay, at a rate of 0.5 meters per second. And in the second second, you're decelerating faster. So those are the three different scenarios when we're reading a velocity time graph. You have positive acceleration, zero acceleration, and negative acceleration. Now, how does this translate to a distance time graph? They're going to look slightly different. And if you remember, when we did the distance time graphs, when you had a change in an uneven change in acceleration, you had a curved line. So basically, if this is our 10-second mark, this is our 20-second mark, and this is our 30-second mark. Remember, you have to keep the scale the same all the way across. In the first 10 seconds, you have positive acceleration. So you start at zero, and it's going to be a curved line. It's going to curve until you hit the 10-second mark. And then, at the 10-second mark, you have a change. You have zero acceleration for 10 seconds. So what's going to happen is that line is going to be straight, and I'm going to try and draw it as straight as possible for 10 seconds. And then in the last 10 seconds, you have deceleration, which means it's going to start slowing down. And remember, it's a curved line again. It's curved until it goes flat where it stops. So this is a curved line. So it's almost like an S-looking figure. So it should look something like this. I don't know if you can see it that well there, but it should go something like this: curve up, straight, then curve down. It should look something like this. And this section in between, in the middle, Where the line is straight is where you would have zero acceleration. And that's all it is for today. So hopefully this helps you when you're working on your velocity time graphs. If you have any questions, please come see one of us, and we'd be happy to explain in further detail if you don't understand. Okay? Have a good day.